So this is a video showing you how I got these calculations for how much mass of air the fan blows and the speed that it was moving at. This is the really tricky number to get right. I'm going to show you what assumptions I made to try to make this calculation, starting with this. So for example, for a 10 centimeter square section of the fan surface, notice this isn't exactly 10 centimeters. If I put this up here, it's a little bit less than 10 centimeters on a side. It's not exactly a square. I don't care that much about that. I'm just trying to get something approximate. So my goal is to time how long it takes for this bag to fill up. I know what the volume of this bag is, and we're going to use that in a second. Earlier when I timed this, I got about 4 seconds. I started basically the timer running when I just hit this button. This time I'm going to wait a little bit in order for the fan to really start moving, because I think that I underestimated the speed because I started it too early. So let's try it. I'm going to start this. I'm going to wait for it to get going and start. And it looks like it's full now, so stop. I think I might have waited a little bit too long. This is like 2.6 seconds. That's a really hard measurement to get right, but I'm going to call it 2 seconds. I know it was less than 3. I know it was more than 1. So I tried to let this bag fill up. It looked like this when I was done. And I'm going to use that information over here to make some calculations. So this is related to basically how fast the air is flowing through this 10 centimeter section. If I think about this 10 centimeter by 10 centimeter as an area, this air is coming through at a specific speed, and I know I let it run for a specific amount of time. So I can actually use that to figure out the volume of air that passed through this space. I know, because I know what kind of bag I used, that this volume has a value of about 50,000 centimeters cubed. This is the same as approximately 11 to 12 gallons, and I know that because that's the size of the bag that I used. Again, I'm going to use a time value here of 2 seconds. That's approximate, but it's close. I don't know the speed, but that's what I'm actually going to solve for. So essentially, I know that the volume is equal to the speed times the time. Basically, like if you imagine a big tube that is as long as the distance that this air travels, that's speed times time, and that is multiplied by the area that it's coming out of. These three things multiplied together will tell you the volume of fluid or air that passed through that opening. Then I'm going to do some substitution. 50,000 centimeters cubed equals speed, which I don't know yet, times time, which is about 2 seconds, times 10 times 10 is an area of 10 centimeters squared. And then I'm basically just going to solve for speed. So I divide both sides by 2 seconds and 10 centimeters squared, 2 seconds, 10 centimeters squared. Some of these cancel, so I'm left with centimeters on the top, and I get a speed of, oopsie, this should say 100, 50,000 divided by 2 divided by 100 equals 250 centimeters per second. Now, I know that I can't use centimeters per second if I'm doing energy calculations, so I'm going to change this to 2.5 meters per second. And if we look back at this over here, notice I got a value of a speed of about 1. Where did I go wrong before? Well, I think it was that estimate of the time. Notice this is the only real measurement that I was able to make, and look at how much the value changes if I use, say, 4 seconds, which is approximately how long it took from the moment I pushed the button. If I do 50,000 divided by 4 divided by 100, I get a number that's half the size. When I follow through to calculate the kinetic energy, that makes a huge difference in the value of the kinetic energy that I calculate. So I think this is probably a better number. I would probably write this as like 2.5 meters per second plus or minus at least 0.5 meters per second. Meaning it could be as high as 3 meters per second, 2.5 plus 0.5, but it also could be as low as 2 meters per second, because I'm just estimating here.